All right, thank you all for coming. I first want to acknowledge that we are packing several big topics into tonight's forum. We could easily host an entire forum on each one of these topics, and perhaps we will in the future. However, the purpose of tonight's gathering is more to not to go into great technical detail with each topic, but rather it's meant to draw connections between the different elements with the hope that we may inspire some holistic solutions to the water crises that we are facing in our region. To provide some context for tonight's forum, I conducted research into the human water cycle for my capstone project during the Master of Public Administration program at Evergreen. And while I was doing that study, the elements that I was focusing on were the ones listed to the left, which are water withdrawals, infrastructure, stormwater, wastewater, climate change, water laws and policy, and society's norms and behaviors. It's not necessarily an inclusive list, and perhaps you can think of some other elements that should be included. Nature's water cycle cannot be fragmented into separate, unrelated elements, and similarly, all the elements of the human water cycle are interconnected and influence one another. For instance, climate change is already having a significant impact on water availability. I'm sure many of you have seen images of how the mega drought in the West is depleting reservoirs, which is impacting recreation, wildlife, and water availability for human uses. In Washington, the summer drought is getting longer and more severe, while winter storms are growing more intense. Less precipitation is falling as snow and more as rain, so snowpack is depleting. Likewise, impervious surfaces from modern infrastructure create stormwater runoff that produces harmful wastewater laden with chemicals, and over withdrawals of water combined with habitat loss, climate change diminishes groundwater stores and instream flows. On a positive note, they are connected in a way that we can use to our advantage and help make our development wiser and more sustainable. For instance, wastewater treatment facilities can produce really clean reclaimed water that can be used for a lot of purposes and help supplement our water withdrawals. So this is all to say that these elements are intricately linked. And I think that's why we're all here tonight, because we care about water. We recognize that water is the most precious resource on this planet, and it literally connects every living being. If you could go to the next slide, please, Paige. So I'm going to start off the forum with just a very brief outline of Washington water law, as it serves the foundation for our state's relationship with water. Of course, other laws and policies such as the Growth Management Act, the Clean Water Act, Shoreline Management Act, Watershed Planning Act, Salmon Recovery Act, and others have an equally significant impact on our relationship with water. But the fundamental principles of Washington water law are that water is a natural resource held in common. A water right grants an individual the privilege to use but not own the water. As soon as water is released back into nature, any ownership of the water ceases and reverts to its common public resource status. In theory, Washington's water law is a mix of the Riparian doctrine and prior appropriation doctrine, but not in practice. In 1917, the legislature adopted the first comprehensive water code for surface water and adopted prior appropriation as a standard for the issuance of water rights. The Riparian doctrine is prevalent in the eastern states and in the UK. It ties the right to use a body of water to the ownership of the land over, under, and adjacent to the water. Unlike prior appropriation, the date of first use is irrelevant, and those whose land is not adjacent have no right to use the water. Prior appropriation was first developed in connection with mining claims on federal land in the arid West. And the earliest appropriation is senior to all further appropriations. It creates a seniority system. In case of water shortages, senior right holders get full use of water, while junior holders must stop using their water. Prior appropriation is also known as first in time, first in right. Water must be used for a beneficial purpose. There's the doctrine of use it or lose it. Water rights are deemed forfeited if not used for a period of 5 years. And there are certain water withdrawals that are exempt from permitting. In Washington State Department of Ecology issues water rights, and they are charged with verifying that water is physically and legally available, that the water is being put to a beneficial use, that its use is in the public interest, and that its use does not impair another water right holder. Some exemptions for requiring water permits are water for livestock, the watering of a lawn or non-commercial garden not exceeding 1/2 acres, single or group domestic uses not exceeding 5,000 gallons per day, and industrial uses not exceeding 5,000 gallons per day. A lot of you are probably aware of that this is a very contentious issue, and there's the big Hearst decision and the Hearst Fix Act that happened over the course of the last 5 years. Not gonna get into that right now, but just that kind of exemplifies how contentious water rights can get in the state. Also, many of you are likely aware that we are facing numerous water crises in the state, and some scholars argue that the Western water law is kind of an unjust way of appropriating water, and it creates a competitive arena that promotes misuse of water. Prior appropriation is premised on the idea that all water in a body of water will eventually be diverted for human uses and closed to further rights. It prioritizes human water uses at the expense of habitat, fish, and wildlife. And essentially any use of water which is related to human needs or is economically productive meets the standard of beneficial use. So perhaps it's time to pursue some alternatives to the way we structure our relationship with water. Okay, with that, I would like to turn it over to Kevin Hansen.
Okay, hi everybody. Let me adjust this guy a little bit here. I'm staying at the office to do this. Welcome. I'm Thurston County's hydrogeologist, and I really appreciate Matthew's overview of water law in this state because I've seen a lot on the East Coast that is the riparian rights doctrine, and it's quite different. So anyway, let me swap screens here and go. Wait for a moment, and then if anybody could tell me if they could see a blue background with that slide on it.
You're good.
I can see it.
Okay, good. Okay, so the title tonight is there water for growth in the environment? And the reason I frame the question that way is because it's not clear what the answer to that question is. So I'm going to phrase it as a question. Let's see. Okay, my second slide, of course, is the big disclaimer, which is it's about data, not politics. So I'm not going to talk about policy, but data. There are a few places where, of course, it's quite tangential. Hook me if I say something that appears like county policy. That's made by the commissioners, not me. So the first slide I want to show is one that's been going around now for several years. Thurston Regional Planning Commission made an estimate of population growth and came up with a really startling number that our population is going to grow by 42% by the year 2040. Now sit back and chew on that for a second. 42%. So, this number is a little bit outdated, and the new census puts us, if I recall, somewhere around 280, something like that. But still, a 42% increase in population makes us sort of sit back and say, where exactly is the water going to come from for that kind of growth? Now let's look at where that growth might take place. This again is a TRPC data-driven slide. The rural county piece that you see on this pie chart here, right in here, can you all see my cursor? Can anybody see my cursor? Anybody can report that? This
Yep.
brownish, yeah, good, thanks. This brownish yellow piece here is the rural county. About 14% of the growth is expected there. The Olympia and Tumwater, Lacey, et cetera, UGAs, urban growth areas, are expected to absorb a little less than half when combined with the county, and the cities are expected to absorb 52% of the growth. So although most of the burden falls on the cities to figure out what to do about this growth, it's an issue for all of us. So let's keep going here. The reason I threw this slide in is that one of the first questions people ask is always, but wait a minute, isn't this a wet county? Don't we have lots and lots and lots of water? Well, the answer is maybe not as clear cut as people would like to think. So I'll switch now to a view of the entire, all of Thurston County. The pink dots are the oldest of the state issued water rights, but of course the overlay is of tribal usual or custom rights that overlay the entire county in one form or another and predate all of them. So they're the senior water rights holders in this area, and that becomes crucially important as we go forward. So I want to point out the brown basin that you see near the bottom of the map, which represents the Scatter Creek Basin. And in 1950, people were very surprised to find out that they could no longer get water rights. It was extremely controversial to begin to close basins in the state of Washington. But that began to happen in 1950 in our county. We were not the first in the state where this happened. But the fact was, surface water was being depleted to an extent that the creek ran dry. And as we look at the 1960s, late 50s and 60s, more basins began to be closed over near Yelm, the basin immediately north of Scatter Creek. As we looked by 1976, the entire southwest corner of the county and the area around Yelm were closed. And by 1988, the entire county had restrictions on the issuance of new water rights. That time lapse is a pretty important thing in my world because it says basically there's no easy water. Although the restrictions I'm pointing out were technically for surface water, because groundwater and surface water are tightly integrated, it's understood now that we can't deplete one without depleting the other. Essentially, it's the same water. And I'd ask everybody to imagine that the water flows in and out of our creeks, but its position is what matters, not whether it's groundwater or surface water. It's the same molecules. So what do you do when all the water rights are gone? Well, what actually happened in practice was that as people found it increasingly difficult to get water rights, they began to drill so-called permit-exempt wells. Well, this became a big issue, and Matthew has correctly pointed out that the modern Hearst decision was a result of the cumulative effects of these permit-exempt wells going in. So they're only about 13% of pumping volume, but they're 96% of all wells. And it allowed development to push out into the rural areas very, very quickly. And now we have about 23,500 pumping wells. That number varies day to day as we learn more. So I point out this snapshot of South County because I wanted everybody to imagine for a moment that you wanted to have a new well drilled in this environment. Look at the number of wells. Almost every single parcel is serviced by a well. They all affect stream flow into the Black River and Scatter Creek and the Chehalis in this case. Imagine trying to place a new well anywhere on this map. And I've highlighted a water rights starting location and change location that was submitted several years ago because the competition is fierce now, and it has been fierce for many years, although almost no one knows about that level of competition. So it's begun to affect our streams, and gain loss studies have been done. In the cases where we see the red and orange bands on this map, including the Deschutes, and look particularly at the red band in the middle Deschutes, those orange and red and yellow bands indicate places where the creek bed is losing water down to the aquifer. And this became a huge issue that we'll look at in a moment for the cities of Olympia, Lacey, and Yelm as part of their mitigation plan. We'll come back to this. The main takeaway here is streams lose water because of base flow loss from groundwater pumping. So on top of this, we have climate change effects. And here, I know that climate change is technically part of the second session on the human water cycle, but I wanted to present a couple of slides because it's so integral to the understanding today. All the bars that point up are indicating streams that are getting warmer. year on in county records. So, anybody tells me global warming's not happening, I just burst out laughing. I'm like, no, we collect the data. There's one stream, Eaton Creek, right here. Eaton Creek is actually getting slightly colder, but not by much. Now, the magnitude of growth, these are 1 degree C increments over the period of record. So the period of record changes. If we look at the next slide, we'll see that every red arrow is a stream which is increasing at a rate that will overtop 13 degrees C in the dry season when salmon runs are beginning to, really be a big issue. These streams are going to become lethal for young fish in some cases. Now, I'm not going to make too broad a statement, but it's a grave concern. It is almost ubiquitous. And although I joke that in our county we have to consider agents like volcanism as part of the causal package that might be causing stream flow or stream temperature rises, in reality, no, because we see graphs like this for the Deschutes River watershed, and these panels represent different reaches of the Deschutes River and different tributary streams leading into the Deschutes River, and essentially they're all rising. Note especially the Deschutes at Tumwater. This has risen just since 2008. This has risen almost 4 degrees C on average. That's a shocking rise. Remember, if you're looking at groundwater fed streams in the late summer, those streams should be cold. In other words, that's winter water that flowed through the system and then erupted into the base of the creek, feeding base flow. Well, that base flow should be icy cold. That's what the fish expect, and that's what our habitats were the evolution pointed toward the usage of that cold water. They're not capable of sustaining that kind of temperature increase. And imagine that the Earth matrix itself has to be warmed up in addition to the water in order for it to erupt out as base flow. So I'm pointing this out as a huge warning signal for all of us that climate change is real, it's happening here, and we need to deal with it. Now, I want to tell a quick story about a mitigation plan, and this is something that Jesse can probably fill us in on a little bit more as far as current, but you'll get the point. Now, I apologize here. This is such a busy slide. I have to apologize, but I wanted you to see the busyness because the complexity shown on this slide that shows the Deschutes River with its gaining and losing reaches. It shows the big orange dots that are pumping wells scaled by size of annual pumping rate. And it shows surface water in blue. And then it shows these little strings of arrows, which point generally from the Deschutes River middle reach where we see it losing water, all the way up toward the massive pumping centers of the McAllister Springs and Wellfield right up in here. Well, the important thing to get is that the idea that we had to mitigate for the new pumping center at that time of the McAllister Wellfield was wise thinking. Folks said, we need to put water back into the creek. So they developed a cooperative plan, and the plan involved Olympia, Lacey, and Yelm. Everyone was excited to see the cities working together. They did a really stupendous job with a very sophisticated numerical model. And you see a cross-section slice through that model. The model showed that there was, in fact, base flow loss out of the Deschutes, and it suggested the magnitude of the repairs that would need to be made. So all of this was the good science that you'd love to see, but darn, reality has a way of interfering. So what happened was that, and you see in this slide, the lavender blob down here represents a mitigation site that was picked and purchased by Lacey, Olympia, and Yelm. And you know what? Sarah Foster sued. She said, your plan's great, but it doesn't put water back in my creek. And she was right. So the lesson here, the takeaway was that as well as we can plan, the density of competing interests and wells and stream flows in here is enormous. It's just enormous. And it's going to be extraordinarily difficult to move forward without bumping into one concern or another and to get it right in every case. And that's a signal that we have reached the point of stress on the water system. There is no more free water. It is all expensive. It is all difficult to get to. And in this case, Sarah Foster had a precedent-setting lawsuit that became known as the Foster decision. I met Sarah. She's a lovely lady. And she came by and she said, yeah, they had a great plan. It just doesn't put water back in my creek and well. So looking forward to the complexities and challenges of this, are there opportunities to, I'll put in quotes here, make new water? And for that, I'm going to take you back to the water cycle. And I'm going to point out that of the 4 bars on this horizontal bar chart, evaporation or transpiration by plants is this big pink bar. Next to it is stream flow out, which is pretty straightforward. And then look at the last 2 bars, seepage out to Salish Sea. And then the last little bar over here, that little bar represents the approximately 75,000 acre feet per year of water pumped out. So although we have a lot of work and effort and huzzah about replacing permit exempt wells consumption, it is such a tiny fraction of the total water budget of our area that I'd urge us to look at the other much larger bars that are controlled by things like land use. So when we look at the Deschutes Basin, the upper Deschutes, maybe we begin to see opportunities there where even a little tweak can have enormous beneficial effects on downstream stream flow. And so I show this slide here, which is an adaptation of a wonderful paper from 2016 by Perry and Jones, where they did studies of basins side by side, one clear cut, the other old growth, primarily in Oregon, but other places too. What they showed was, and this is important to get, as soon as you clear cut, all the water rushes off. There's nothing to hold it in place. So that means wintertime flooding happens immediately after clear cutting. And then as the young trees begin to regrow, they begin to suck up a huge amount of water and stream flow begins to decline. So that wintertime recharge is still absent because the young trees are drinking it. And it takes another 40 or 50 years before that creek will begin to build back the stream flow that the older trees were capable of holding. And it takes about 100 years to get back to the equivalent hydrology of an old growth forest. So one of the options is to let trees get much older in certain basins in order to improve stream flow. And I think there are a lot of potentially productive proposals for doing that. Right now, the Vale Tree Farm, which is owned by Weyerhaeuser Corp, is a major tree forestry operation. And if you go up to the upper Deschutes, it looks like World War I. You have vast areas blown off at knee level, and the clear cut operations. It's a crop in the eyes of the companies that own those tracts, but it's also an opportunity for improved stream flow. I know, for example, that the Nisqually tribe is actively buying recently cut land in order to accumulate land for a new forest that would be a community forest where stream flow improvement and salmon habitat improvement are both likely and very exciting. Take a look at their plan if you're interested in how that works. So I'm almost done here. I wanted to point out this slide because water banks are a really sizable opportunity for accumulating unused rights and distributing them at, pardon me, at a cost which allows future development of those water rights. Now, the bar size here is related to the cost per acre foot of water. That's how it was normalized. And the large number of tall bars over here on the left represent private water banks. And the smaller bars over here are public or quasi-public entities as the water bank. So if we were looking for a Deschutes estuary restoration technique, for me, one of the options is to start a water bank. It would be complicated, but well worth the effort, I think, because bigger projects like storing water, big changes in land use can be envisioned by a water bank governing board. And the watershed plan that did not yet pass when the RIA committees were developing response to the Hearst decisions fix law, the ESSB 6091, the option to organize a committee was on the table, and dirt was proposed. Sue knows about this. Dirt was proposed as one of the players at that committee. It was a good idea then, and I think it's a good idea now. And I really hope that that's one of the outcomes as ecology is developing the rules for the basin. Sue, you may know more some details on that. So here's Kevin's interim water report card with a big asterisk that says this is Kevin's opinion, not county policy. We've got population growth of 42% expected by 2040, exclamation point. What are we going to do about that? Remember that the water rights in Tumwater are fast expiring. In other words, they've used them all. Even the water rights in Olympia are good out to, I think, Jesse, correct me if I'm wrong, but 2060, which is not forever. You know, now it's less than 40 years away at current growth rates and expectations. And development pressure, very high. Stream flows are too low and exacerbated by pumping. Water temperatures are too high and rising. There are few water rights available. We are already competing over the land needed to do mitigation projects of various kinds. The mitigation is essentially unavoidable. It's competitive and it's very, very expensive. And we should expect that lawsuits are going to happen. They're just unavoidable also. The good news is, my gosh, of the bullet items here, I've only got one piece of really good news. Groundwater availability is good with some difficult areas, but remember, groundwater will be good even when our streams are dry. So that's the downside. We can have, you know, since we're dependent on groundwater pumping, our wells may look terrific, but the streams could still be dry, which would be a horrible outcome. And I'd hate to see that happen, but it's one of the things people ask all the time. Just, well, aren't our wells okay? The answer is yes, but does that compensate for the streams being dry? Okay, these are general statements I'm making. And everything I've said is extremely fast, overview, and generalized. There are exceptions to every rule, and we should talk further about those. So, Matthew, I'll hand it back to you.
Thanks so much, Kevin. I appreciate it. And I will now introduce Jesse Barham from City of Olympia. You may have to stop sharing your screen, Kevin, to be able to transition.
Okay, thanks, Matthew. 1 second, let me get my screen share going. How is that?
I can see it. Looks good.
Okay, great. Well, thanks for being here, everybody. Jesse Barham. I work for the Environmental Services section at the City of Olympia. We're part of the stormwater utility. So I'll just provide a little overview about stormwater in Olympia and what we're doing in that regard. And so just a quick overview, hopefully. So just a little landscape context. We're here in Olympia, the very southern tip of the Salish Sea in South Puget Sound. It is a formerly glaciated landscape, and the soils are heavily have been heavily influenced by that glaciation. We've got about 50,000 people in the city of Olympia itself. We are at sea level up to almost 400 feet in elevation, and we've got about 20 square miles roughly of land within the city limits. About 90% of that's land and 10% of that is water of various types. So since we're talking about stormwater, that all derives from rainfall. So here's a graph that shows the last year of rainfall from University of Washington. We are averaging, the lighter blue line is our average rainfall and how it's distributed over the year. The darker blue line is our actuals in the last year. You can see we're slightly above average in the last year, but our average is just approximately 50 inches of rainfall a year. And much of that infiltrates to groundwater. Some of it flows off to surface water. And stormwater is when that falls on impervious surfaces, and then it flows off quickly into natural areas, aquatic habitats, pipes, etc., eventually down to Puget Sound, just like all the water. Here's the rainfall events in the last year by date. You can see that the bulk of our water falls from the sky between October and June, usually more April, May is really the bulk of it, but really between November, December, January, February, a little bit into March is where the bulk of those events occur. You can see those big peaks here. Early January, we had a very large event, over 3.5 inches in 24-hour window. It was probably more than that if you're not counting the 24-hour window from midnight to midnight. And then early September, we had, or early mid-February, we had another 3-inch event. So you can see that, you can imagine how much water is coming off the landscape, especially if that landscape does not allow it to infiltrate. So the storm and surface water utility in Olympia, it's a community service. Ratepayers in Olympia, community members pay rates for this service, and the utility is mandated to manage floods, maintain and improve water quality, and protect and enhance aquatic habitat in the city of Olympia. And first, I'll touch a bit on the aquatic habitat piece of that, since really that both the forested landscapes that allow that water to infiltrate, typically in natural areas like Kevin was talking about, up in the forests, as well as all the wetlands, streams, and lakes and aquatic areas within Olympia are really, they perform many of the functions that we're trying to mimic with the stormwater infrastructure that's built. So here's a map that shows generally an overview of the aquatic habitats in Olympia. We've got 8 small stream basins, several small lakes, and a number of glacial kettles. Those glacial kettles don't have a surface water connection. They go direct to groundwater. The Deschutes River estuary is within Olympia, currently Capitol Lake. There is approximately 680 acres of mapped wetlands that were interpreted from aerial photos. They're not exact, it's just an estimate, but almost 700 acres of wetlands is the estimate. Most of our streams are relatively small, have minimal salmonid use, but have relatively decent water quality and macroinvertebrates compared to streams in larger urban, more developed areas up north. So here is a map from 1854. The very first map, the General Land Office survey map of Olympia, is what's on the left. You can see you've got a tiny little grid of Olympia. You've got wetlands up, and this is probably not extremely accurate. They were really mapping the shoreline and kind of general patterns across the landscape. But you can see Schneider Creek is on the left there. It comes out of some headwater wetlands that are probably up near Division and Harrison at this point. And then it flows down to Puget Sound, Bud Inlet. You've got on the east side, you've also got wetlands up there. Mission Creek is a remnant of that, Mission Creek Nature Park. You've got Ellis Creek. And then in the middle of the photo there, you've got the downtown Olympia. You can see the old original Deschutes estuary on the left, kind of going to the south there to the mouth of the Deschutes River. To the right of downtown Olympia at the time, you can see a large wetland complex that's really where Indian Creek and Moxley Creek come together. It was probably a large salt marsh or just a really wet marsh on that side, on the east side of the bay. On the right side of this slide, you can see the various fills that occurred in downtown Olympia starting in 1870s. Over that time, since 1876 up until present, there is over 430 acres of land that was aquatic habitats, mudflats, salt marsh, etc., that was formerly part of the Deschutes estuary, and 1.9 miles of new shoreline. So that's been a huge change in the habitat and downtown Olympia in that time period since the 1850s. So why do we care about aquatic habitats as the stormwater utility? These aquatic habitats provide a ton of process-based functions that are very similar, that provide all these environmental ecosystem services related to water. Streams convey water, wetlands and lakes remove sediment and nutrients. Riparian areas also remove nutrients and sediment. Both wetlands and lakes are attenuating flows and protecting downstream areas from flooding and the impacts of flooding. Aquifers are recharged through wetlands, as well as riparian areas providing shade. This is just a short list. I'm sure I'm not capturing them all, but there are a ton of processes, natural processes that are provided by these aquatic habitats. They're some of the most important habitats on the landscape, both for water quality and quantity, as well as fish and wildlife habitat, providing food, water, and shelter for a huge array of species. Just one example, this is out at Grass Lake. On the left, you have Grass Lake in the summer. Not completely dry, but relatively dry, covered by a marsh, an emergent marsh of emergent vegetation. On the right, you see it in winter. There is probably approaching 100+ acre feet of water storage in Lake Louise. That is really protecting lower Green Cove Creek from the impacts of upstream areas along Cooper Point. Parts of the mall around Capitol High School all flow to this area. And these wetlands are providing a huge amount of natural function, both for attenuating flood flows as well as filtration. This is a graph from a document that a colleague of mine put together in 2013. I think it was, I forget when it was finalized, but maybe 2016, the Habitat and Stewardship Strategy. This illustrates a bit of what Kevin was getting at about that growth. These are land cover changes across Olympia from 1994 to roughly 2013. You can see a very large loss of forest, both conifer and hardwood, as well as grassy areas and shrub. Not much of a loss of marsh habitat or wetlands, but this is largely a result of the Growth Management Act that is directing, like Kevin said, 50% of that growth projected to occur in the cities. So I've lived in Olympia since '99, and the huge areas in the west side and in southeast Olympia were forested at the time when I moved here, even 20+ years ago, that are not now, that are subdivisions. The wetlands areas are relatively stable. They're protected by both state, federal, and local regulations, as well as stream and riparian areas are as well. But this is just a snapshot of some of the habitat changes in Olympia in the last 30-ish, 25, 30 years. So the Storm and Surface Water Utility has been involved in a decent amount of wetland enhancement and protection type projects. This is an example from Mission Creek Nature Park, where a large area of reed canary grass, probably approaching 5 acres, over about 3 years, we converted much of that to willow habitat that provides a lot more functions for nutrient uptake as well as wildlife habitat. You can see we put in these living sticks in the ground, and then 3 or 4 years later, you can see they're approaching 20 feet tall, really trying to bring that area back to a higher level of function. So on to stormwater and impervious surfaces. So when that rainfall falls on pavement, concrete, roofs, parking lots, it flows off the landscape very quickly. Across Olympia, there are, I believe it's approximately 3,000 acres of impervious surfaces across the landscape in Olympia. And when water falls on those, it quickly transports a lot of sediment and anything that's on those impervious surfaces into stormwater runoff. And that water carries a lot of pollutants downstream, which mostly eventually reach streams, wetlands, and Puget Sound, that inlet. Here's a map that shows the impervious surfaces by basin in Olympia. The greener the polygon, the more natural land cover remains. So you can see Ellis Creek has only 11% impervious up in far northeast. It is mostly forested still. Green Cove has 18% impervious. Chambers is around, I don't see it on the list, but it's still relatively forested. You get down into Bud Inlet and the Port Peninsula, and it is about 80% impervious. So this is a little snapshot about how those impervious surfaces are distributed across the landscape in Olympia by stream basin. And research from the last 20 years plus shows that streams are typically pretty heavily impacted by impervious surfaces at around 10+% impervious surface in a basin. So the potential pollutants that are in that stormwater include sediment, which is also many other pollutants are attached to that sediment. It's kind of an analog that we use we try and capture as much sediment as possible, both within catch basins, within treatment facilities, stormwater ponds, et cetera, because the bulk of the pollutants are really attached to that. Some of those pollutants include metals like zinc and copper, which are extremely hazardous for juvenile salmon and really affect their sense of smell and homing ability. Nutrients like nitrogen and phosphorus, which can affect DO, dissolved oxygen content in marine waters for nitrogen and in freshwater for phosphorus. Bacteria like E. coli, pet waste is a large source of that, as well as potentially failing septic systems. That's a problem for human contact, as well as any shellfish growing areas. Also, a ton of tire and brake wear on many of those high capacity roadways. Some very recent research shows that coho pre-spawn mortality, they've correlated it to one of the tire additives, 6-ppd quinone, is shown to be heavily toxic to coho salmon, that if it's at high levels in their streams that they're returning to, they often die before they can spawn, as well as oil leaking from vehicles, car accidents, and spills, etc. So many of these pollutants are the things that we're worried about. So the built infrastructure, we call it gray infrastructure, stormwater in Olympia. The photo is outfall of Moxley Creek. In Olympia, there are around 160 miles of stormwater pipe that are publicly owned, an additional 144 miles of privately owned pipes. Those can vary anything from 5 feet, 6 feet in diameter, like Moxley, down to like 6 or 8 inch diameter pipes in local developments or in small areas. There is 7,400 publicly owned catch basins. So those are the grates you see in the street. They have a sump below them that is intended to capture some of the sediment that falls in there. Those catch basins, per our permit to discharge stormwater to receiving waters, mandates currently that we clean those out with a vacuum truck every 2 years. So we're capturing a ton of that sediment that way. There's also 5,700 private catch basins in the city. There's 300 flow control and treatment facilities that are publicly owned, and over 1,300 privately owned facilities. And one of the big issues is much of this infrastructure was constructed before there were strict regulations as there are currently. Past practice was, the idea was, back 50s, 60s, 70s, even into the 80s and before, was get the water off the landscape as fast as possible to prevent flooding. Now we realize there are some real negative impacts of that approach. Here's a map that shows the publicly owned infrastructure that we were just talking about. You can see kind of how it's distributed across the city. On our website, we have some maps that are interactive that you can zoom in on your neighborhood and see what is the stormwater infrastructure on your block, in your neighborhood, or anywhere around town that you're interested in. One interesting thing to note is there's about 20 miles of combined storm sewer pipes. These are where stormwater flows into the sanitary sewer and eventually flows to lot. About 330 acres of town has this system, combined sewer. It's the blue polygons on the map there. And really, this is the best high quality treatment provided anywhere. Lot has the most high-tech nitrogen removal system of almost any water quality treatment plant in Puget Sound. So this is really great, but it also moves water around in ways that have other consequences as well. But really an interesting thing that we have some parts of town, mostly downtown, a little of Northeast, a bunch of South Capitol area, all float a lot. So these built facilities that I'm talking about, we've got everything from filters that are cartridge filters that have oftentimes a combination of carbon and other filtration media in them. That's shown on the left, one up off Giles Avenue, right at the kind of headwaters of Schneider Creek. Also detention facilities, infiltration facilities. This is a sediment catchment pond in the middle that's part of the Yager Park stormwater facility. And then on the right, you've got a filtration system that's a curb cut where water right off the street flows into a vault that has filter media in it and also vegetation. In addition to built infrastructure and hard, pipes, catch basins, treatment facilities, ponds, there's a ton of other things to stormwater that impact stormwater water quality. Street sweeping is a huge one. It's a huge preventative action that if you can keep the streets clean, you're picking up all that sediment and associated pollutants before they get washed down into the storm system. Olympia recently got a grant from Ecology that's helping us acquire a second street sweeper that we're buying this year. And the street sweeping program recently moved from the transportation department to the stormwater utility. Like I mentioned before, those catch basins and a lot of other treatment systems that capture sediment are vacuumed out. That's what you're seeing in the middle there. We also have inspection programs that both inspect those private facilities as well as public facilities to make sure they're all being maintained and are currently functioning. Other types of things that really impact stormwater are education and outreach to the community to help everyone understand how their individual choices affect stormwater and water quality. You can see here some outreach materials for businesses that have dumpsters to keep those lids closed, because anytime water gets in those dumpsters, it usually ends up in the street and in stormwater. So there's a ton of different education outreach and behavior change programs, including picking up pet waste, et cetera, as well as responding to spills is another large part of the program. Stormwater is extremely complicated. There is just a ton of different factors across the landscape that impact water quality and stormwater, and it is an extremely complicated topic that is really, people that are involved with it understand it's hard to find something that doesn't impact stormwater. So that's what I had about stormwater. It was just a brief overview of a complicated topic, so happy to field questions later.
Thank you, Jesse.
See about stop, there we go, stop share.
All right, and now we have Katrinka from Thurston Conservation District joining us to talk about shoreline modification.
Hello, everyone. Let me see if I can turn on my video as well so you can read my lips if you're hard of hearing, as I am. I'm from Thurston Conservation District, and Thurston Conservation District is a non-regulatory special purpose district that works with community members to address natural resource concerns on a voluntary basis. And so we work with a lot of people on shorelines and a lot of agricultural property owners, and then people who live on rivers who have concerns as well might reach out to us about their concerns about erosion or that sort of thing. So one of the programs that we have grant funding for is called Shore Friendly Thurston, and that in particular is focused on improving shoreline habitat. And one of the biggest concerns right now along with shoreline habitat is shoreline armoring. And so that'll kind of be the focus of what I'm talking about, but many of the things about armor on marine shorelines is very similar to river armor as well. So it's just, so I just thought we could start by talking about what I mean by armor. So bulkheads made out of concrete are one of the armor forms that you'll see. Wood bulkheads also are considered armor. There might be creosote in them, or they might be just natural wood that's degrading, but it's having an impact on the shoreline. And then riprap, rubble, and then sometimes people even just use concrete bags of cement that they throw out there and stack to create a barrier and slow down erosion. One of the things I heard in the opening statement was social norms and community behaviors, and I think that shoreline armoring is one of those things that as people were moving into the area and putting their homes on shorelines and along rivers. Armoring was something that was just kind of done whether they needed it or not. And now houses are, people are getting, as we heard, populations are increasing and the houses are getting closer together. And so there's a lot more pressure to feel safe on the shoreline, and armor is one of those kind of reactions. So I just wanted to look at this image of the marine riparian area and the functions that it provides. We've heard about all of the great benefits of trees and shading the water and keeping it cool. And marine environments is particularly important because trees overhang the beach and provide insects and detritus to the shoreline, and that feeds the marine invertebrates that are in there at the top of the beach. And then also the forage fish find that area really important for surf smelt spawn up in that upper beach. And shoreline armor kind of impacts whether they're able to spawn on those beaches. So I have a little graphic here that kind of talks about how shoreline armor inhibits forage fish spawning. In a natural environment, the beach, forage fish would spawn in this area that's, let me see if I can use my arrow here. Can you see my arrow in this place? Anyway, they have kind of a large area where the tide's coming in and out, and there's quite a bit of space for spawning to occur. But when you have armor on a shoreline, that really abbreviates that beach and makes the area smaller. And then as we're dealing with sea level rise, the beach will kind of transition up with sea level rise, and that the area where spawning habitat is can migrate with that sea level rise. But when we have bulkheads on the shoreline, all of that upper beach is lost, and the forage fish lose that opportunity to spawn in that area. Another thing that bulkheads do is, shoreline processes include erosion and wave action. And when you have a bulkhead on the beach, the wave action and tidal action hit that bulkhead and create accelerated energy and erode below the bulkhead. And you'll see changes in how the sediment on the beach is distributed, and it's not as fine. And so the forage fish aren't able to spawn in those areas as well. So since this is a real brief overview, I'm just going to jump to looking at river systems and how there's different morphologies for those, meandering rivers and anabranching and braided. But I wanted to talk about how armoring affects the ways that river systems change as well. And so this is just a really, I was having a good time with the animation in PowerPoint. But so this is a river in Thurston County, let's say, where houses are being developed and people are building their houses. And as they do that, this is another one of these social norms things. People like to cut down trees and put in lawns, and trees are particularly important in stabilizing banks. And so here we're adding a lawn, and soil stability is not as good. So many people move into this little river system and cut down their trees so they have nice views of the river. And then they start to see a little erosion, and so they think, well, I'll put in a bulkhead or some sort of bank armor. And when bank armor is added to the river bank, you lose the complexity that's provided by natural or shoreline vegetation that slows the water and moves it in ways that keep it moving at a slower pace. And we heard about stormwater hitting pavement and leaving the system quickly. The same thing happens with armor. It speeds up the velocity with which the water is moving. And so then it becomes impactful downstream. And so one person's protection of their little property transforms into increased erosion downstream in front of somebody else's. And so it's one of these compounding situations where someone else sees increased erosion, and so they want to armor their bank, and the system just continues to speed up, and we see more and more erosion. So that was just my little graphic to try to describe that. And erosion often leads to trees falling in the river, which is actually a great habitat benefit. But people get worried about that as well, and often want to remove them, and or get concerned about what's going to happen when they move downstream. So anyway, I'm going to move on to just a real brief. This is from the Marine Waterfront Guide to Protecting Your Property while Promoting Healthy Shorelines publication from Fish and Wildlife, and it has some really good points about how to manage shoreline properties in ways that are beneficial to both the people who live there and the environment around them. So one of the biggest points we've heard several times today is to keep your trees. And if your trees are already gone, please replant some, reestablish trees that might have been taken out. But maintaining trees really helps with stormwater management and slope stability protection and slows erosion. So it's important to keep them there, and then leave fallen trees where they fall, because they also contribute great habitat benefits. And when they fall on beaches, they're providing additional woody debris in rivers and on shorelines, and that adds complexity and shade, and helps with accumulation of sediment as well. And then when you're restoring or maintaining your property, use native plants as much as possible. And things like English ivy on slopes really creates these diversity deserts that inhibit the benefits of having vegetation on the shoreline or anywhere at all. Another thing that homeowners can do to really protect their slopes without putting in armor is to manage their drainage well. And some things you can do to do that are to minimize the size of impervious areas. So try to keep your driveways small, and if you can, use pervious pavers or some other way of hardening the surface for driving. Keep your house footprint small so that it's also a smaller impervious area. And then make sure that you develop a system to manage your stormwater that is well managed, so into pipes that are contained and all the way to the base of your slope. And then collect and treat the water that you're gathering in those pipes, and make sure that it gets all the way to the base, because if you let that water out at the top of the slope, you'll find you'll have more problems with erosion. And then make sure that your outfall is a good dispersion method that doesn't increase erosion. Like we said, keep the house footprint small if possible. And then if you have trees, keep them. And if you don't, plant some more, because they're an important part of our systems here in South Sound. Another solution to excuse me, houses that are too close to eroding edges is to move them back, and so choosing your house location, if you haven't built yet on a piece of property, as far back from steep slopes as possible is really the best idea. If you have the opportunity to get a variance because your neighbors are too close to the shoreline, and you could also benefit from that, or you think you would, don't make that choice. Put your house as far away from the slope as you can. And move it back if necessary, to protect the beach. So in South Sound, this is from the WDFW's parcel segmentation report and the coastal atlas that ecology has, and all of these red marks along the shoreline are armored shoreline armoring. So we have about 82 miles of residential shoreline in Thurston County, and almost 42% of that is armored, or was when that report was done. So I have a few examples here of bulkhead removal projects that have happened. This one's local, out on Eld Inlet, and this concrete bulkhead was removed, and this is the result. Shorelines are often look a lot messier than people are used to once they're in a natural state, but this is very important habitat and has lots of benefits to the shoreline processes. Beaches are made up of sediment, and when there's a bulkhead in the way, the process of erosion doesn't allow for sediment to be contributed to the beach and results in these hardened, more cobbly beaches. This is out at Fish Trap Estuary. All of this riprap was removed, and this is the resulting restoration. And then I liked this bulkhead removal image from up north a little bit farther, because it shows that when they took out the bulkhead, they made sure to install a lot of trees as close as they could to the shoreline. So those are some bulkhead removal projects. And I just wanted to say thank you for letting me speak about armor on the shorelines. And I feel like I could have said quite a bit more about the Shore Friendly program is funded by Fish and Wildlife and EPA and the Estuarian Salmon Restoration Program. So if you have questions, feel free to reach out, or you can request a consultation at our website at thurstoncd.com. So thank you.
Thank you. And with that, I will turn it over to our last speaker of tonight, which is Ted from the Center of Sustainable Infrastructure. And then after that, we will have roughly a half hour for question and answers. So if if you all organize your questions, we'll have a panel afterwards. It's on to you, Ted.
All right. Thank you, Matthew. Thank you, everybody. I'm not going to be presenting any slides or images, and I'm not going to be really throwing any data at you. So you're more than welcome to grab a beverage, lean back. I'm just going to talk a little bit, and I'll try to do this quickly so we can get to the good part, which is Q&A. So you just heard, I'll just sum it up, tons of challenges in this space. A couple I would add onto even what we've heard already is privatization of water scares me a lot. Well, I should also say first, I work here in Olympia at a small nonprofit called the Center for Sustainable Infrastructure, and we're about trying to get a whole lot more value out of the massive amounts of dollars that we spend on infrastructure. And we think that we can get a whole lot more through innovation, through integration, through systems approaches from our infrastructure spend, and that's a pretty great way that we can change the world. And so that's kind of our mission at CSI. But so my talk tonight will both be informed by that work, which I've done for the past few years, and also I spent 10 years at Ecology, much of those with Dave and Maria there, and the last few as Director of Ecology under Chris Gregoire. So I might have more of a state perspective. So some challenges I'll just add on to the already impressive list of challenges. Well, first I'm going to say just thank you to the people who have gone before me, both for those presentations, but also just for the really cool work they're doing in the world on this stuff, and particularly Katrinka, who came out and actually advised me on all that stuff on how I can use, more natural approaches to manage the very stormwater influenced creek that I live on. So thank you for that, Katrinka. Also for powering through like a pro through the coughing. That was very impressive. That's tough. So the Clean Water Act is a funky beast. It was made in 1970 for the world of 1970, which was all about point source pollution and big pipes with big pollution. But the 2022 world is a very different world with, we've got now mature point source regulatory systems in place, but very immature and inadequate tools for the pollution that, is really bothering us now, which is non-point pollution or population pollution. But politically, no one's going to touch the Clean Water Act because once you open it up, then it's vulnerable to being weakened, and that would be a terrible thing. So we've got this increasingly outdated tool, but no real avenues to update it that are safe. Another one that I learned over time at ecology was, there are limits, and we haven't reached them yet, but maybe some communities have, but there are ultimately going to be limits on what I call the environmental dollar. How much are people willing to spend, and how much can people afford to spend on environmental infrastructure solutions that cost a lot of money? So wherever that time is, there is a ceiling, and that worries me. And it then begs the question, how can the spending we do be prioritized according to not just today's challenges, but tomorrow's challenges, and not have the spending be prioritized only by the sort of Clean Water Act mandates or the most the latest lawsuits, which are good forcing mechanisms, but it doesn't necessarily allow us to make what we're going to have to increasingly make, which is strategic decisions about prioritizing those environmental dollars. And just bringing it home here, and I really applaud both tonight and just the work that you guys do as an organization. But on the Deschutes here in Washington State's capital city at the bottom of Puget Sound in 2022, I love hearing the news at the outset that the preferred alternative for the EIS is restoration. But I also have to say, man, it's 2022, duh, right? There is this ticking clock in the world that is ticking ever louder in our race to secure a livable future. And while people, as you've heard here tonight, especially here in Thurston County and Olympia, it's just some wonderful things are being done by wonderful people in the space of water, and there's much to take hope from there. Every single one of these topics can consume not just a career, but generations of careers. This is hard, complex, consequential stuff, and we need to move faster. So I'm going to kind of shorten my remarks here so we can jump ahead. So while we could talk for days and days about the challenges in this space, we know that they're numerous, they're huge, it's already late, we need big solutions, and we're not really on track. At least not with the ticking clock that is only getting louder. Okay, so that's going to conclude the complaining portion of my remarks. And so now let's talk about, so what might being on track look like? And there's really two ideas that I want to offer tonight around that question. First is about integration. You folks are, I'm imagining, a pretty smart audience on this stuff and may have heard about this sort of ever emerging and more and more common approach or concept called One Water, which is basically and Matt talked about it earlier. And I'm sorry, I don't know if you're Matt or Matthew, but so Matthew talked about it earlier, which is we should be, instead of disaggregating all of these different components of water, instead, we're moving more toward integrating across all facets of water holistically, and that only makes great sense. And so it's a necessary evolution, and we could talk all night about this, but I'm not going to. Instead, I want to talk about integrating water management, water policy with issues beyond water, to what matters just to us as people holistically. Water alone, the kind of stuff we've just been hearing, solving these problems does require and will continue to require huge amounts of dollars and huge investment of political capital. solutions are hard to come by in this space, and they're always met with resistance, and that's why progress is slow. So I want to offer this thought that we should instead, or in addition, I guess, be asking more and more, how can these expenditures be leveraged for multiple benefits that serve multiple values? And some of those values that aren't necessarily water centric, but very much touch water and water touches them is, one is prosperity. I mean, that's just however you define prosperity. And I don't mean being a, billionaire, but everyone wants to have a certain amount of security in their lives. And that's just an essential human value. Equity, is how we handle water fair? What about public ownership versus privatization? Is it affordable so that everyone can afford it, not just, some folks? Environmental justice, is there clean, affordable water for all? What about climate change and clean energy? Big intersections with water on that. Ecosystem function. Now more, we have to be thinking about green hydrogen production, electrolysis that uses water as its source there, wildfires, and lots more, right? There are all of these values that matter to people that water touches beyond the stuff we're talking about tonight. So I want to give a little example here of a project that we've worked on that is really cool, and I think highlights a few things. So this is in the city of Pasco. There's a lot of food processing that goes on out in Pasco. And basically what happens is, with a lot of those food processors, they send their water to a facility that's owned and run by the city. And then the city does some measure of treatment, and then basically land applies that water to crop circles. The water is high in nitrogen, so it's not very valuable agricultural, irrigation water. So it grows low value crops on, some of the most productive farmland there is. Just as a way to get rid of this high nitrogen water. But that is adding to the nitrogen in the water table, which is a problem, and ecology saying, you guys got to knock it off and change something here. So they've been looking at solutions that cost up to and even upwards of $150 million just to do more of that. And that might mean just buying more crop circles and applying more of this water across a greater sort of spread, but that doesn't really solve the nitrogen groundwater problem. It just sort of keeps them in legal compliance. And for that kind of money, just to sort of continue doing the same it just isn't very satisfying, given the ticking clock, and all these challenges we face. So we worked with them, and there was some public money that funded this. And through these principles of integration, of a systems approach, and of valuing these multiple values, right? Not just around denitrification of the water, but just saying, all right, all of these values, whether it's jobs, whether it's affordability in a Latino majority community, for water infrastructure, how can we meet multiple values if we're going to be spending this kind of money? So here's what they came up with as we worked with them. So instead of just buying more crop circles and putting more kind of crappy water to raise low value crops, what they're now moving forward with is a system that would take that water, run it through anaerobic digestion, capture renewable natural gas that gets put in the Williams pipeline in Prosser, a denitrification system built on a passive algae system where algae is grown and denitrifies the water. And then they could capture value from the algae, either as feedstock for cattle, as feedstock for bioplastics. If it's the right kind of algae and they feed it to cows, that can even lower their methane emissions from, burping and farting cows. Also, as we create that algae basin, that allows them to store water in the winter, which cannot be land applied because the water's up, the lands are frozen and you can't land apply. Just creating that extra storage would allow food processors to run year round and instantly create over 200 jobs, mostly for the sort of Latino workforce there. So this is an example of integrating not just sort of across their water management, but across multiple values. This also includes, or could include, and hopefully will include, a new dairy gold processing facility that sends their water into this system, both capturing renewable natural gas and potentially using their what's called cow water that could be used for greenhouse agriculture. It's really good for growing hydroponic crops. And another one that we're exploring is the local waste collection company, now has to worry about and deal with methane emissions from post-consumer food waste. So some of this water could go to an anaerobic digester to mix with all that food waste to create renewable natural gas as well. So this is just one example of how we can take a much more integrated approach that then not only gives you a lot more value and benefits, but also offers a lot more value to the community, which then opens up doors both to sort of broader community support, as well as, a lot more potential funding sources to make cool projects like this go. So that's my first thought, is integrating not just across water management, but beyond water, and to the greatest extent we can, looping in and serving other essential human values. Second thought I want to offer is this quote that I just cannot remember who said it, and Google didn't help me. But the quote is this: "The 21st century will belong to those with the best stories." And I think there's just a ton of truth to this. And water just is, just as we're sort of experiencing tonight, it's complex, it's multifaceted, it's hard, it's combative, it's despair inspiring. It's just all of those things and more. And a sort of simple but inclusive vision at the level of core principles is really elusive, right? So it's really hard to tell a story that says, here's what the future of water should look like in a way that we can all understand and get behind. And I think that's important. We need a way, at least I do, to hold all of this stuff in our heads and say, for the livable world of 50 years from now, so for the livable world of 2072, here's what we need. And so that people can say that to their policymakers, to their neighbors, so that we can start moving in that direction, instead of a complicated laundry list from Western water law reform to stormwater retrofits to redesigning cars so every time you brake, you're not killing fish. And, sort of diffusion and confusion in this space will remain our enemies in making that kind of transformative progress that we need. So I believe that vision should prioritize things like public benefit, public ownership, pollution protection. But what I want to offer tonight is that I think it should also reflect this concept, which is this. It's called the tyranny of the or and the genius of the and. And this is coined by Jim Collins, who wrote like business leadership books, and I didn't read them, but I know about this quote. I always should have read more of those, but couldn't make myself. And here's the concept: the tyranny of the or is what it sounds like, right? It pushes people to believe things are either A or B. You got to choose. And in water, that means, so is it farmers or fish? Is it cars or fish? Is it power or fish? Is it industry or is it healthy people? Is it moneyed interest or is it the public interest? Is it white people or is it Indians? I mean, this is our history. This is, for millennia, this has sort of defined our approach. But now we have not only the opportunity, but I think the absolute need to liberate ourselves and evolve to the genius of the and, which is about embracing sort of both extremes of a question and a number of dimensions in between at the same time. And I would add to that it means solving multiple problems by valuing multiple essential human values of sustainable environment, sustainable prosperity, and sustainable communities, and striving in every decision we make to serve all of those values as fully as possible, instead of just refereeing between those interests and deciding this one or that one, which is kind of how we've done things. I've actually come to believe this is the essential evolutionary step that we need to make to win this race against the clock and survive and thrive in this new age of the Anthropocene. So in Europe and more recently here, so this is happening. We are moving in this direction, and I think it's awesome. But we need to do it bigger, and we need to do it faster. So some examples in Europe, and more recently, it's just starting here. People are seeing wastewater treatment plants, for example, not just as sort of cost centers, but value centers. I mean, there's so much thermal energy that is lost that could be gained and valued from wastewater, and we're just starting down that road. Fortunately, we live here, and the lot is way out in front of most places. But the reality is, this part of the world, we're ahead of, most of the rest of the state. This state is ahead of most of the rest of the country and most of the rest of the world. So all these challenges we face, and we're in better shape than most places. So that, that's kind of an alarm bell, I think. In Pasco, the example I gave, the sort of the first example of what they want to do is just full of or choices. But instead, what's available to them if they take this other approach are, and solutions with multiple benefits coming out of this investment. Here in the Deschutes, it's been a history of, is it a, lake or estuary, healthy ecosystem or enjoyable human amenity. I'm not going to get into sort of what is the right solution there. At one point, I was a couple hours away from being hired by Chris Liu at DES to be the consultant on this right before they decided to stay in-house with that. And I'm really glad that ended up that way, I think. So I don't have the answer to the capital lake solution, but what if a restored estuary was, if we look outside of just the water pieces and was combined with this wonderful, compelling vision that included a wonderful human experience along West Bay and an eco-friendly plan for the old brewery on the river, and to reframe this from human versus natural and make it human and natural, and serving multiple values in that space. So I think that's where I'll end here. My last word is and that rather than always just focusing on redoubling our efforts to win these fights, how can we sort of step back and transform those fights into possibilities for shared wins by embracing the and it doesn't mean there's not going to be fights. There's going to be plenty of fights, and but it could mean fewer fights. And by taking this approach, I think it can also make it harder for narrow interests to win over broader public interest. And as that happens, I think the livable future becomes just more and more possible. And maybe the last thing I'll end on is that so we're not starting at ground zero. We're starting with Western water law and hundreds of years of, we got a lot of holes to dig out of here. But one thing that I think is true in the world is, as we have seen unprecedented rates of change and things that, just the last couple of years, things that you just couldn't have predicted. Change is happening at rates and scales we've never seen before. And so the positive thing I want to end with is that also means that, what has been impossible in the past, which includes big transformative progress towards solving these massive challenges we face, we can't say that is the ceiling on how fast and how big we can change in the future. God only knows. So I find hope in that what we're talking about tonight doesn't have to continue to be, sort of fighting every year inch by inch, but at some point, it's the analogy I like to use is surfing. When you're out there surfing, there's time when you have to really use a lot of muscle to build up speed and try to catch that wave, but then you have to recognize what's happening underneath you, and sometimes that wave forms and you have to move, you have to shift from that that hard work of trying to just slog through this stuff and make progress, but then all of a sudden your job is to jump up and surf it. And I think we're approaching surfing in the world, and through efforts just like your organization are making here. So I'll stop there, give folks time for questions, and thanks very much for having me tonight.
Thank you, Ted.
Thank you, everyone. We really appreciate all of your expertise. I'm going to open the floor to questions at this moment. Didn't see any in the chat that weren't already answered, but if you want to turn your mics off, cameras off, and talk to us, we're open to any conversations. Everyone's contact information is listed on the screen here. Just a reminder that we will be sending out additional resources in the next couple of days. So we have two participants raising hands. Matthew, my screen is taken up by the screen share if you want to facilitate that.
Yes, first I just want to check. Kevin, if you're here, can you say hello? I know Kevin said that they're leaving in the chat, but I also noticed that they're still logged on as a participant. So maybe they just left their office and accidentally didn't sign out. All right, I'm not hearing anything from Kevin, so I'm assuming that they are not around. So I will first go to Dave and Maria Peeler. It's the first hand raise that I see.
Yeah, thanks, Matthew. And I want to thank all the speakers tonight. Great job, everyone. And Ted, if you're still on there as well, one of the interesting things about watching what's happening in these different areas, and you're seeing the same thing, is that it's sort of a knee-jerk reaction when we hire consultants to tell us, well, we got to fix this problem, and they have an off-the-shelf solution, right? And it's usually the one that we've been doing for the last 20 years, been, maybe it's some new bells and whistles, but it's the same one. And it doesn't really look outside the box, And when you mentioned, I think, or someone did at least, the lot treatment plant and what they've done with, satellite facilities and water reuse, hardly any of that has been done in our state, even though everyone has had the same opportunities as Lot has, for the last 20 years. Some of that's because Lot was kind of forced into it, as you know, because of the problems in the Bud Inlet area with nitrogen. But still, you'd think other places look at it. And the reason I bring that up is that has opportunities for multiple benefits, so, and to Lot's credit, they're still studying that to make sure that they get it right, and we don't have other problems associated with it. And you can probably look across the board at most things. Stormwater, it used to be, as Kevin or somebody said, it's get rid of as fast as you can. Now we know that's a problem. and there's other things you can do with it, whether it's rain gardens or whatnot, to help not only slow it down and take the pollutants out, but to create a better environment. So, I mean, I like your approach, Ted, because I think you look across some of these environmental problems. There's a lot of solutions that can have multiple benefits, but we still tend to go to the off-the-shelf one because that's the easiest. And it's also the thing you can point to when you say, well, it's going to cost X millions of dollars because we know how to do that, but we don't really know how to do this other thing like you were describing, because we haven't done most of those yet. And we haven't figured out how to maybe quantify those multiple benefits. So it's not just about doing this one thing, but these others as well. And does that help offset that cost? Anyway, so I think we have a lot to learn on these multiple benefit type approaches, and we certainly should be looking at them more and more. And I think Sue Patton had her hand up, but she also put in the text, that for what we're thinking about at DIRT, for the Butt Inlet and the Kappa Lake and the Chutes Estuary, really, we were thinking about multiple benefits as well. We weren't just thinking about let's take the dam out and have an estuary, but what can the estuary bring us that we don't already have in the way of recreation and other human benefits, and tying it better into the whole ecosystem here of the lower river and into Butt Inlet, as opposed to it's treated as some other kind of water body. Anyway, so enough of me talking about that. Thank you again, all of you, for being here tonight, especially you, Ted. It's nice to run into you again.
Thanks, Dave. A quick comment on that. First, those comments were in no way directed at DIRT, just speaking generally. And also, just one cool thing I'm seeing. So I totally agree with everything you said, and we're both working at the space or at the level of demonstrating these through actual projects in communities, and also trying to scale it. And one of the cool things that I'm observing in the world is that just in the last couple of years, under this administration, federally, there's a new thing, which is these agencies that hand out gobs of money for projects and infrastructure. They have a new mandate that has to do with multiple benefits, and it has to do with things like, well, how is this project helping climate change? How is this advancing equity? What about environmental justice? And so that's really great news. And my experience is most of those folks are going, I have no idea how to do this. How am I supposed to take my program, which has always been single focused, and do this? So there's at least now an appetite I've never seen before. So we want, let's all rush in to fill that and answer those questions so we can scale this a heck of a lot faster.
Well, I'm going to jump in because my hand's raised, and I'll just say what I have to say.
Go for it, Sue.
So, first of all, I want to thank Paige and Matthew for this lineup and this forum. It's really been interesting and educating, and good job for the first one this year. It's a good job. Thanks, Dave, for saying what I was going to say here in terms of DIRT's vision for this overall project, and how that vision fits into what we're going to be involved in the next year, few years, 20 years. We've already been doing this 20 years. We might as well do it till we die, I guess. But the Deschutes Watershed Council is going to be formed, hopefully, if we can get some funding, with all the jurisdictions, with interested environmental groups, to look at all of these water issues and the interconnection between the water quality and water quantity issues we have in the Deschutes watershed. And Ted, these things you're saying about kind of the human infrastructure part of it, and how we look at how do we value like prosperity and environmental justice and all those things, how do we bring them into this so that we're almost prioritizing those actions, not against all the little piecemeal things that we deal with, like what kind of runoff is in the stormwater and all those little pieces that we have to deal with on an ongoing basis, and certainly without opening up the Clean Water Act. Good Lord. But it's just really helped me think about this Deschutes Watershed Council and the breadth of not only the water issues in terms of connectivity between quantity and quality and how that all works, but all those things that bolstered those connections, the stuff you were talking about. I really, really appreciate how you're doing this Center for Sustainable Infrastructure. I'd like to talk to you some more about it. And maybe when we get the council up and running, at least the initial kickoff, so we can have you come in and give us one of your lectures. but thanks, this has been great. I really appreciate all the speakers. It's been really good.
Thanks, Sue. I'd be honored to do that.
I just want to quickly respond to Al had posted a question in the chat before that relates to kind of the technology with wastewater treatment. We will be really talking a lot, like part 2 of the forum is going to focus on wastewater treatment facilities, nutrient problems in Puget Sound. We'll have representatives from LOT joining us. Dave Peeler can talk about the nutrient general permit from Department of Ecology. So that question might be better asked during part 2. From my understanding, I don't believe that the technology to eliminate all the new things they're adding to the system, such as drugs and caffeine, that wastewater treatment facilities have that technology to filter that stuff out. I don't know if Ted's able to speak to that at all.
I'll just say this, how can I make a quick comment on that? This is a perfect example of the need for integration. This disaggregation where it's like, we're only talking about how to deal with all the crap that's in the water, whether it's pharmaceuticals or other stuff, without in any way being able to connect to decisions about how that stuff either was or wasn't allowed in the first place, and upstream possibilities. That lack of it all being a connected system forces us to make these stupid decisions in a very disaggregated way that end up being super expensive and not very effective. And so I'll just make that general comment that you have to be able to, and this has been really hard to do, but this is where we're evolving to, is to again take that holistic approach to management and policy to get at those challenges. I mean, the fact that you can just, a company can just make wipes and say these are disposable, and even if this is going to cost taxpayers, ratepayers with local infrastructure $1 gazillion, that doesn't matter. There's no mechanism to discourage them from doing that because of those downstream effects. So that essential sort of disaggregation prevents integrated, smart, efficient, cost-effective solutions that have to be a bigger part of our future.
All right, now it's Amy has a question. I'll turn it over to her. Oh, you're muted, Amy.
Sorry, thank you. First of all, thank you to everyone. I have learned so much tonight, and I appreciate it. And you all being here and doing this incredibly complex work. I don't really have a question. I have a few thoughts, things I haven't heard about. Heard a lot. I'm very interested in Ted, how you discuss new approaches and this ticking clock that we're on, and really looking at the rights of water as an entity, and our place in the ecosystem in which the water and the land are have agency of their own. And in that, I'm curious and wishing that there was Indigenous voices here, that there were Indigenous leaders and knowledge keepers bringing that perspective too, because I do think it's time that we all work together and have all voices at the table. So I would be really interested in the next one, April 19th, if that were a part of it, of bringing in other voices, specifically Indigenous voices. And again, thank you all so much. I really appreciate everything here. night.
Thank you for your comments, Amy. We will work on that for the next forum because I definitely agree with you.
I have a question for Jesse. I'm just curious. I'm somebody that I really am fascinated by some of the low impact development techniques of ways of like different stormwater treatment facilities they can do with constructed wetlands or bioswales or filtration and media boxes with the tree planters. And I find that stuff like really compelling and am curious what that actually looks like on the maintenance side for the city. How hard is it to maintain those things? And like places like Yager Park, is that like a system that once it's established, it can maintain itself to an extent, or it takes a lot of active management? And can it meet, like, I don't know when Yager Park was designed and constructed, but is it holding up to the present demands of stormwater runoff today as impervious surfaces continue to spread?
I'll throw a couple ideas out there on that. So I think depends on the facility, obviously. A lot of the bioswales and things in the right of way, I think there's, like we're talking about multiple benefits. They have aesthetic value, but that also requires a high degree of labor to maintain an aesthetic value of a landscape kind of implementation. And what are people's expectations about that? Olympia just reorganized part of the utility to have a crew that's focused more on vegetation management and on landscaping, and they work for different parts of the city, but the stormwater utility is a big part of it. As far as additional maintenance needs, something like Yager Park, it goes a lot about how they're designed has a large impact on the maintenance needs. So many of these facilities have smaller cells, like, well, 4 bays or small cells that are intended to capture the bulk of the sediment in an easily maintainable situation or part of the facility to prevent the larger part of the facility from needing maintenance to remove sediment. So those kind of solutions can be implemented on a bioswale scale too. But those are designs that are, there's definitely a lot to do with how they're designed and how they're maintained. I think Yager, for an example, I think at some point, many of these things that look natural at some point may need to be maintained and sediment removed from the larger areas. And that would probably be a shocking change for some folks in the community that are used to assuming that it's maybe even a natural habitat. But those are factors that the utilities that we're constantly dealing with about how are those things going to be maintained. And a lot of it comes down to how well were they designed in the beginning. So. Did that answer all your questions, Matthew?
Well, it does. I have, I know that Olympia put this like low impact development ordinance in place in 2016, where it'd just be like the preferred method, but it seems like with modern development, or like the development that's been continuing since that time, it doesn't seem like there's much low impact development actually putting into the new developments downtown. They put a few plants around, and I guess that's supposed to help control some of the stormwater runoff. But when you actually look into like a manual of low impact development, there's so many techniques that aren't being utilized and that we could be taking more advantage of. And just things like green roofs, which I find really compelling, but I don't know that that'll ever actually take root here or how long it will take. In other countries, they use that technology a lot more.
Yeah, one of the things about downtown is that most of the stormwater infrastructure that is kind of LID type infrastructure is designed to manage flow volumes, a little less on the treatment side. And currently everything that discharges directly to saltwater is exempt from that criteria. So it's only would need to be treated for filtration or water quality treatment and not flow. So that is partly the case in downtown. The other parts of the regulations get to one of those big challenges like Ted's talking about, is about the nexus to require someone to retrofit an existing development where there's kind of this shifted baseline theory, like it's already impervious surface. We're not going to force you to treat the impervious surface you have unless there's a huge significant change in the facility. It could be reoccupied by someone else to do something different, but not, just an occupancy change is not a nexus for a retrofit project. So that's kind of the, if it was a parking lot that got changed into a building, there are going to be requirements, but some of those requirements are not going to be related to the change isn't as if it was a forest to a parking lot or to a building. So if that makes some of the nuance there.
Thanks. It looks like Amy has another question.
I have a question this time.
Yeah.
I'm curious about water catchment and water catchment law in Thurston County. From what I understand, San Juan County is the only county that it's legal to collect and filter or purify catchment systems. Is there anything that this is in support? Would this be supportive of these impervious surfaces? And
I don't know the legal answer to that. That would be something probably for Kevin or Ted to answer, but there is, it is a benefit to capture that water and reuse it. As far as the legality of it, Ted probably knows better.
I may be outdated on this because I've been away from the gig for a little while, but this is one that it's like a good example of a challenge that's like, wow, this is kind of a complex challenge, because on the one hand, catchment sounds great. And on the other hand, what if it goes to scale, right? And then all of a sudden you're interrupting the whole groundwater infiltration cycle and all of that. And so, I think that it's been, and this was, and we took a crack at it, and then like, God, that didn't work, and so I don't know if it's changed since then, but basically it was sort of a don't ask, don't tell policy, sort of gray area, like, well, if people are doing it, no one's going to come and enforce on you. But we certainly can't say this is a policy we bless, because then, what if it goes to extremes? And so I think this is an example of an issue, and I'm, not giving you a very satisfactory answer, but where it can, a thing like that can just sit there stuck in the water policy world for years and years and years, because a fix is really hard, but no one wants to go and enforce on it. So people just sort of, do their thing. And that's kind of been a county by county approach. San Juan, they have just serious water problems that have, really forced them into saying, hey, we are doing this. And, who's going to come in and say, hey, stop that, truck water in instead. But anyway, that's my sense of it's one of those like, yeah, this is sure kind of a tough one, and let's kind of dodge the answer. And I don't know that that's really changed in the last few years.
If it's okay, Ted, this is Dave Peeler. I'll add just a little bit to what you said. I think you're right about, how it's stuck there, and the worry is, and the fear is the same as like with the six packs for development. It's like it really catches on. It could be a real problem for watersheds. But in at least two cases I'm aware of, the building in Tacoma that the Peterson Partnership occupies does catch water off the roof of the building, and it is filtered and then reused for things like, flushing the lavatories and things of that nature, and a little bit of watering around the vegetation around the building, but not for human consumption. And I think the same with that new foundation that built that huge new building up near the Space Needle in Seattle a few years ago. I think they also capture rainwater at that facility, as well as have solar panels on the roof and all that kind of stuff. So there's a few where, some large buildings have been built that do some rainwater capture for that same kind of use, that is flushing toilets kind of a thing, and maybe some irrigation, but that's it so far. I'm not aware of really much of a large scale outside San Juan, like you just said, where it's so dry anyway, and there's not a lot of rainfall to capture to begin with up there, but there is some.
When we shut down several years ago over this fight over permit exempt wells, the Upper Kittitas to further withdrawals, and that then forced them to try to go there on rain catchment. Just an example of how challenging this will continue to be. I just learned about this new technology where even in the Sahara, apparently you can do this, put up these sort of big sails in the air, and then by applying this electric charge, it just sort of sucks water out of the air and then collects it. And so it's like, oh, wow, that sounds awesome. But then it's like, well, what happens when that gets taken to scale? Are you interrupting, you know, so God knows. So these challenges are not going to get less complex.
All right, well, we are at 8 o'clock here. So I'm going to wrap things up. I'm going to pull together a list of resources to share with all of the participants. I know Ted works for the Center of Sustainable Infrastructure. They have some really great reports. And one of the reports that they wrote is on water. And it was really helpful to me when I was doing my research for my grad program. And there's some great information there. And all the speakers have shared a little list of resources that I will send out to everybody. If you want to dive deeper into the topic, and you have their contact information if you want to ask them questions directly. And a reminder that part 2 will be focusing on nutrient pollution, Puget Sound, wastewater treatment, and climate change. So thank you all again for joining. Have a good night.
Thank you.
Thank you.
Would like to volunteer with us or know anyone that would be great for another forum or to lead kayak patrol, please get in touch with Matthew or I. Thank you everyone for being here. Have a good night.
Good night.
Bye.